This is the complex ion formation lab, and the complex is going to be the iron +2 and then the olefin, which is a ligand that will attach the iron, either 1, 2, or 3 of them, and that's what we're going to figure out, is how many of the ligands attach to the iron. And we're going to determine that by taking different amounts of these solutions to create different concentrations of the iron and the olefin, and we're going to then make up 12 different combinations of those, and then we're also going to have a blank. So we're going to have a lot of solutions, and we're going to run each of them in the spectrophotometer that we're using. This is the Spectronic 200 spectrophotometer, and we're going to put our samples into these cuvettes, and then those are going to go in one at a time into the spectrophotometer, and we're going to see how we're going to send in a particular wavelength of light and see how much of the light is absorbed, and that's going to change as we change the amounts of iron and olefin that are present in our solution, in each solution. And from that information, we're going to determine how many of the olefin ligands are attached to the iron. So what we need first is a blank that contains only the iron 2 ion. So I'm going to add in 1 ml of the iron 2 ion solution. And then that's going to go into this 25 ml graduated cylinder. And to help with it, we're going to have to add water to this cylinder, so might as well put it in here to help transfer it. And then just make sure I get all of that iron. I'm going to fill this up and do it again. Okay, so pretty sure all the iron that was in here has been transferred here. And then we need to fill this all the way up to the 25 ml mark. So that's just diluting the iron 2 solution. And then we put this into, that's considered the blank. So we're going to put it into this Erlenmeyer flask, and we have our blank. Okay, now we got to make the rest of the solutions, all 12 of them. Now what we want is the same amount of iron 2 plus solution in all 12 of them. So every solution will have 1 ml of the iron 2 solution, but then we're going to change the amount of olefin. The first sample will have, well, the blank had none of this. It only had the iron. So this one will have 0.5 mils of the olefin. Sample number 2 will have 1 mil, and then sample 3 will be 1.5 mil, and then it'll go 2, 2.5, 3, 3.5, all the way up to 6 mils for sample 12. But we'll always put in 1 mil of this. So I'm going to wash out the graduated cylinder in between sets, or between solutions. So that's at 1 mil for the iron, and then I got to be careful, this is going to only be a half a mil. Really hard to, okay, there it is. Okay, so this is our half of a mil, 0.5 mils of the olefin solution. And so this is going to go in here with a lot of water. So since we want to make sure we get all of the solution, I'm going to wash it through a few times. And that also washes out the 10 mil. So I don't have to worry about that. I can just set it over here. Oops. For now. And then I fill this the rest of the way up to 25 mils with water. Distilled water, of course. And we put this in. And that's our first sample that contains the ofen. So we're going to, so I'm going to do the other ones, but I won't do them on screen. You can see that it's just going to be the same kind of thing. So sample 2, I'm going to put in 1 mil of the iron 2 ion solution, and then 0.1 mil of the ofen. And then I'm going to pour that into here, fill it up with water. It goes into sample 2. And just going to keep increasing the amount of ofen by 0.5 mils each time until I have all 12 of the solutions. So I'll just come back after I get that done. It's probably best for me to do that anyway. You really have to focus, make sure you don't make any mistake on the amounts that you're putting in for each one. So let me do that. Here are all of the samples. There's the blank. And each one, there is an increasing amount of ofen at 0.5 mils. You can see that the color changes. It gets deeper and eventually seems to level off. And that's more or less what we'll see with the data from the spectrophotometer. Okay, here is the cuvette we'll be using for the blank. This is what's going to go into the spectrophotometer. And I've already washed it out with water, distilled water, and then I washed it out a few times with the blank solution. Just make sure that it's clean. And I'm holding it on either side here. You can see that arrow. That's the side and the opposite side where the light is going to go through. So we don't want to touch those. And I'm going to be wiping those sides down with a CHEM wipe. I'll fill this up most of the way. Let's make sure there's enough solution here that the light is hitting solution and not air or the surface of that solution. So this is set to go into the, I'm going to wipe it down and take it over to the spectrophotometer. Okay, here's the screen for the spectrophotometer. And you can see that it says freeze display. That is, you can see where the wavelength has been locked in. So we're only going to look at one. That's the wavelength that will give us the highest absorbance for these compounds we're dealing with. And let me pull away. And we have our, let's see here. We have our cuvette, and we're going to open this up. And I've wiped off the cuvette, and I'm going to, put this in to the spectrophotometer. Make sure that the arrow is pointing in the right direction. The light's going to be coming through in this direction. All right, we'll close this. Now, what we need to do, what's in there is the iron plus 2 solution, and we want that to be invisible to the spectrophotometer. It won't see it if we zero it out. So you can see this button here. This is the 0. Press that. And you can see that hourglass and the absorbance. And now it's zeroed it out. So the iron 2 solution will not absorb any of the light, or it will be ignored, so that when we look at our other samples, the iron plus 2 will not be seen in the absorbance. All right, here are all the solutions that I've used and their corresponding samples in these 12 cuvettes. The only one that's missing is the blank. I already used that one to 0. So I'm going to take each of these and put them one by one into the spectrophotometer and see what the absorbance is for each. Okay, a little technical difficulty. So what I'm going to do is take each of these cuvettes And I'm going to wipe off the sides of them. I'm going to get my gloves on, but wipe off the sides of them. Then they go into that holder. Then I'm going to close the door and then show the absorbance. That's what I was going to do, but if you go back here, when I was trying to just show everything, the screen gets really washed out. So what I'm going to do is, instead of showing each of these, I'm going to just put them in one by one and lock on the screen so you can see the value. So I think from the blank, you know what's going to happen here as far as inside, and we'll just focus on the data. Okay, so I'm just going to run through each of the samples. So here's sample 1, goes in, and that's its absorbance, 0.05. Okay, that's what's nice about this, when you just put them in one by one. I'm wiping off each of these with the CHEM wipes. Whoops. Here's sample 2. And the absorbance should go up because we're putting in more and more of the OFEN. So we're getting more of the complex ion that's created. Make sure I got the right. Make sure I get it the right way in here. So 0.15, that's for 3. For 4, sample 4, 0.23. And then we have sample 5. 0.29. And then sample 6, whoops. Sample 6. 0.36. Sample 7. 0.38. Sample 8. Make sure the cuvette is clean. 0.37. And then sample 9. 0.27. Oops. And we got, where is it? Okay. Sample 10. 0.38. And sample 11. 0.36. And then sample 12, 0.36. So those are the 12 data points that you'll have and that you'll be using to graph.